Hello class, my name is Professor Dillon Paul, and today in our pre-calculus class we're going to be discussing about the rate of change. What is the rate of change? Great question. A rate of change is a rate that describes how one quantity changes in relationship to another quantity. So, for example, if x is the independent variable and y is the dependent variable, then the way you find the rate of change is this. So here, we have the rate of change, which is going to equal to the change of y over the change of x. That's the basic formula for the rate of change. Now there's many different types of rates of change. A rate of change can be either positive or negative. So this basically corresponds that it could either increase or decrease. But there's always a certain exception in which case the rate of change can be constant and be at zero. But class, we'll get to that in a bit. So let's talk about the positive rate of change first. Alright, so the positive rate of change is when the values of x and y increase. So basically the graph is going to slant upward. Let me show you guys how to do that. So basically we have a graph like this. Make sure you label your axis x and y. We can just kind of make something simple like that. Of course you have to put a 0 down. Put one point right here, and basically this is just what a basic positive rate of change graph is going to look like. You can see your x values and y values are constantly increasing. Moving on, now we're going to talk about the negative rate of change. When the values of x increases and the values of y decreases, so that means the graph's going to slant downward, that's going to have a graph of a negative rate of change. Here's what it looks like. So again, we're going to have a basic graph like this. You got to label your x, your y, have a base 0, and put a point right here and go down like this. I'll make this part up, doesn't really matter. But as you can see, the x values are increasing and your y values are decreasing. Your graph is slanting downward, which shows the negative rate of change graph. Finally, we're going to discuss the special occasions graph, when we have a 0 rate of change. Now that is when the values of x increases and the values of y remains constant. So there'll be no change in the y value at all, but what that makes is a horizontal line. Let me show you. So again, last time, have a nice little basic graph. Label your axis. If you don't, you're going to miss points on the test. So basically, you're going to have a point here and go straight across. As you can see, your y value remains constant. Your x keeps going on, but that's what makes the 0 rate of change. Now, it's time for a little example. Alright, so now time for our example. Sorry about that, erase the board. I didn't want you to watch that. Alright, so let's give you a little example. So say we have, let's make a t-chart. So we have x and y. Let's label our x, driving time, in hours, and we'll label our y, distance, in miles. Let's just use some basic numbers here. Let's go 1, 2, 3, 4. So we'll go up to 4 hours right now. And we'll go by this. Let's have a number 40, 80, 120, 160. So by looking at this, I'm sure you guys are all smart, you're in college, you can kind of tell, what you're increasing by each time. But for instance, say you didn't know. Here's how you'd find out. You'd use the formula of the rate of change that we discussed earlier, the change in y over the change of x. So what that means is we're going to take two numbers here and two numbers here, and we're going to use the same numbers here and here, and that's how we're going to find the change in y and x. So for instance, let's find the change of y between these two numbers. You're going to take y sub 2 go 80 minus 40. That's over the change of 2 minus 1. And that's going to give you the rate of change of 40 over 1, which is going to equal 40. So right here, you have a rate of change of 40. Okay? Now you always want to make sure for every one that that's the constant rate of change. So it doesn't hurt if you try it again over here. If you take 120 minus 80 over 3 minus 2, and what's that going to give you? That's going to give you 40 over 1 is 40. So here you can see we do have a constant rate of change of 40. Now, let's graph that so we have a visual. This is right here. So we'll label this 40 our rate of change. We'll just say ROC for now, rate of change. Our graph is going to look something like this. Label your X and Y axis. Now we already know our y-axis. Let's make it a little more fancy. You can label this distance. And this driving time. And we'll go by increments of 40, just because we can see. Sorry. $200, and we'll go 1 hour, 2, 3, 4, and 5. So we'll go to our graph over here. We'll go to 1, go up to 4, 2, go up to 80, 3, 120, and 4, 160. We'll draw a straight line. No, that's not straight, but I don't have a ruler or anything, so that's straight. And we have each point here. So if you wanted to know the rate of change, you'd go back and do our formula. As you can see, the x-axis is continually increasing, so is the y, so that makes our graph a positive rate of change, like in our previous example that I drew over here. Hope you have that in your notes. Now another technique that's pretty easy to do if you wanted to find the rate of change between each points is the rise over run. You can count up how many spaces up and over to find out what your constant rate of change is. So we know that our point is 40 and the next point is 80 here. We count up until we hit wherever this median is, and we know this is 40, and we know it goes over 1 because we counted over 1 space, and so our rate of change is 40 over 1, which is 40. So if you're in a rush, you don't have time to do the math, you can easily count up and over, or you can count to the side, go over 1 spot and go up 40. You just do the count over. It's 1 over 40 still. Equals 40. So that is the basics way of finding the rate of change or rise over run. I hope you enjoyed our lesson today. If you have any questions, please email me. Actually, don't. Thank you.